Here's step 4. So for step 4, we're going to take our limiting reagent to solve for everything else that we had, including our product and including our other reagent that we had, our excess reagent. So what we want to do is we've already actually taken a look at using our limiting reagent. And if you remember in the last video, we said that our limiting reagent was chlorine. We already solved using our grams of chlorine for sodium chloride. So we already did that step. When I had 32 grams of chlorine, I determined that I was able to make 52.73 grams of sodium chloride. So we've done that part already. In this step, step 4, we have to use our limiting, which was our chlorine. So I'm going to use my grams of chlorine that I was given, which we said was 32 grams of chlorine. And this time I want to solve for the sodium. So if I have 32 grams of this, I want to know how many grams of this will I use. So what I'm starting out is my grams of chlorine, changing it to moles of chlorine, changing that to my moles of my sodium, and then coming out with my grams of sodium. Take a look at how to do this. So I've got my 32 grams of chlorine over 1 to start. Let's multiply by our conversion factor. Let's put grams of chlorine down on the bottom in my next step because I want to cancel that out. Grams of chlorine down on the bottom. I'm going to, moles of chlorine. So I'm taking this grams of chlorine, going to moles of chlorine. And to do this, I have to look at the periodic table. So I'm going to pull up the periodic table real quick. Again, we did this earlier when we looked at chlorine. There's my chlorine. My mass of it is 35.45, I should say. And we said that chlorine will just have a mass of 35.5. But since I have 2 of them, I have to multiply this by 2, so my mass of my chlorine will be 71. So we have 1 mole of Cl2 is equal to 71 grams of Cl2. 71 grams on the bottom for every 1 mole. Let's multiply by another conversion factor now to take our moles of Cl2 into moles of Na. So multiplying by a conversion factor, the moles of Cl2 going down the bottom, I want to cancel those out. Going to my moles of Na. Oopsie. And let me just put this back here. And to do this, I'm going to use the numbers from the balance equation. So looking at my equation, I have a 2 next to the Na, so I'm going to put that in there. And I have a 1. Let me just get this infinite cloner on here. I just don't have the right thing on. There we go. This 1 next to the Cl to convert from moles of Cl to moles of Na. So I've gone from grams of Cl to moles of Cl to moles of Na. Now I got to do one more step here, taking my moles of Na and converting them to grams of Na. So I'm putting this next step here. Draw a line. Like so. And let's put our moles of Na down on the bottom. And I'm trying to go to grams of Na, so I want to put that up on top. Let's get this conversion from the periodic table. My mass of sodium is 22.99, so we will use the conversion that 1 mole of Na is equal to 23 grams. So 23 grams up on the top for every 1 mole. Let's take a look. Let's do our math. Up on the top, I have 32. I have 1. I have 2. And I have 23. And when I get that, I get 1,472 up on top. Down on the bottom, I have 1, 71, 1, and 1. That gives me 71 down on the bottom. That means that I will use, in this reaction, I will use a total of 20.73 grams of Na. So what I just did was I used my grams of chlorine to solve for the grams of Na. And this number right here is telling me that I'm only going to use 20.73 grams of sodium in this reaction. So all the other stuff is going to be left over. That's why it's called our excess reagent. So that's how you do step number 4. Let's take a look. Press next to check out step number 5.